Hello guys, my name is Engineer Holiday. You are welcome to part 2 of addition of vector. So that means this one we have been looking at addition of vector, but in this case now we are trying to look at the complexity of vector, addition of vector. Now we want to look different methods of solving addition of vector when it comes to a complex case. First of all, we are going to look at the first one is vectorial representation method, and the second one is parallelogram method. Now let me start with parallelogram so that we can now link up with vectorial representation method. Now in parallelogram method, we need to know what is a parallelogram, law of vectors. In fact, that is where you are going to start from. Now what is parallelogram law of vector? It states that when two vectors are represented in magnitude and direction with the adjacent side of the parallelogram, it says that the resultant of these two vectors must be drawn or is drawn from their common point represented by their or represented by what? Magnitude and direction of what? With a diagonal of the parallelogram. That is to say, a resultant force is drawn from a common point with a diagonal representing magnitude and direction of the particular what? Two vectors. What we are saying in essence is that let's take this one as one of the vector and let's take this one as the other side of the vector. So now let's take this as the direction, this arrow as the direction. Now these are the two vectors. Let's say vector A and vector B, and these two vectors are what? Inclined at an angle theta. As we say when two vectors what are represented in their magnitude and direction with the adjacent side of the parallelogram. So these ones are two adjacent sides of the parallelogram. It says the resultant force or the resultant vector is drawn from the common point represented by a diagonal in magnitude and what? And direction. So this direction and this what? You can see representation as direction. Now let's close the parallelogram. Let's close it up. Let's complete it. We have this. Then we have this. We have completed the parallelogram like this. Now let's call this one. This parallel to this one. While this one is parallel to this. Now in this case, now these two vectors, since they are inclined at an angle of theta, this angle theta, now this place is corresponding to this angle here. This is also theta. We call it corresponding angle, angle theta. Now if that is angle theta, now we understand that here is angle on a straight line. This line is angle on a straight line, and here will now be what? 180 minus theta to complement that angle. Now what we are going to do is to supplement the angle. So now what we are going to do now is to what? Let's name this one A, vector A. Now to find the result and considering triangle OPQ, if you consider triangle O, considering triangle OPQ, or probably what we can say QOP, where the reference angle we probably were taking, but let's take this one as our main angle OPQ. That means this one is our main angle that we are considering. Now we are going to see that that angle, that triangle has two sides and one included angle. And for you to find the resultant of such, this side, which is facing that included angle, we use cosine rule, which now be what? R squared is equal to what? A squared plus what? B squared minus 2AB cos 180 degree minus theta. Then if you want to find the resultant, to make R resolve the formula, this square, just take square root of both sides. We are going to have what? square root. If you take square root of both sides, that's square root of a square plus b square minus 2ab cos 180 degree minus theta degree. That will give us the what? The direction, the resultant. This is the resultant. Resultant R. So if you have gotten the resultant R, resultant vector R. Now, how do we find the direction? Now, if you consider the triangle, let's draw the triangle here. Consider the triangle again, which is what? This one is 180 minus theta. This is R, this is O, P, Q. Now, this is alpha, which is direction of the resultant force, alpha. Now, we can now use cosine rule. I mean, sine rule. Using sine rule. Using sine rule. So, we are going to find what? This particular alpha. How do we do that? We are going to say R. What is the angle facing R? The sine of the angle facing R is equals to what is it? This one is A. Don't forget, Y here is what? B. So we are going to take the side what facing what? Alpha, sine alpha. Then from here you can get your vector. Maybe probably if you cross multiply, you would have R times sine alpha equals to what? A sine 180 minus theta degrees. Now from there you can now divide both sides by R. Divide both sides by R. If you divide both sides by R, this one will cancel this one. Then to make alpha the subject of formula, you can say alpha equal to take sine to the equal the other side. Now because sine inverse of A sine 180 degree minus theta degree all over R will give us the what? The direction. So this one is representing the direction. So you don't mix it up when you are writing. This one is what? The direction of the resultant vector, while this one is the magnitude of the resultant vector. Now, we want to look at vectorial method, but I want to come from that triangular parallelogram method to explain something here. Let's draw the parallelogram again. Now this is what? Let's say A and this is B. Now this is the angle we call 180 minus theta initially, though we are not using it. This is our R. Now let me clean it because I want to do something here. Now this is the angle theta. Angle theta. Now in vectorial method, we will resolve A into two orthogonal vectors. That means into two perpendicular vectors. One on the right hand on the y-axis, the one on the x-axis. Let's say this one will now be ax and ay. So that means vector A is having what? Ax, ay. Now we also resolve vector B into two dimensions, which is what? B will now also have what? Bx and by. Now in vector we can also write this one as what? Axi plus ayj. That means the one A resolve on the y-axis, on the x-axis, and A resolution of A on the y-axis, which is j. Don't forget, j is the unit vector. I is the unit vector of x, j is the unit vector of y, and k is the unit vector of z. To show the directional part of all these axes, you understand? That is what we call. Don't forget, unit vector is a vector that has magnitude of 1. It's a vector that has magnitude of 1. So let's say this one is b x I, and here is, let's say, b y j. Now that means now you can write it like this, like a row form, and this is what coordinate form or vectorial form. Now let us now find what the resultant. Now for us to find the resultant, look at the arrow. This arrow is going like this, this one is going like this. Now if you check the arrow direction of vector b, is going like this. Check arrow direction of what vector a, is also going up. That means it's a continuous. If you move from the tail to the tip of the diagram, you will discover that is a continuous movement. That is to say that, and if you check, the resultant force is against the movement. So in that case, our arrow vector will become what? Vector A plus vector B in terms of what? Resolutions. Now if you want to write it now, that means we have to add all these vectors together and add it with what? Vector A added to vector B. If you do that, you're going to have R is equals to what? Ax plus bx will give us what? Ax plus bxi plus then the y-axis is added together. That means component x, we add component x, y component y, we add component y. We are going to have ay plus by j. So that means in this case now, this one becomes what? Like rxi, while this one is ryj. That means the resultant component of the two vectors along the x-axis, while the resultant component of the what? Of these two vectors along the y-axis. Resultant vector along the y-axis ry. So how do you find the resultant, total resultant now in magnitude? You are going to have resultant vector in magnitude. That be what? Rx square plus what? Ry square. That is how to find magnitude of that. Then how do you find the magnitude of direction of this vector using vectorial method? It now give us what? Alpha or tan alpha is equal to ry over what? Over rx. In that case, we are going to have it as what? Alpha equal to tan inverse of ry over rx. So that's what we are going to have. Now if you work on this further, you will discover that this particular equation will give us the same thing as that of parallelogram law of vector. It will give us the same thing. Let me show you something here. Now resolve this one into this a into what? Horizontal and vertical. We would have what? A cos theta going forward, while here we have what? A sin theta going upward. A cos theta, if you resolve this because it's inclined to the horizontal, it becomes what? A cos theta. I've mentioned resolution of vector. I've done video on resolution of vector before, so go and check. Then if you resolve this A along the y, it becomes A sin theta. Now we already have a B along this direction before. So if you do that, if you resolve it now, what we are going to is we have rx becomes what? A cos theta plus b. That's what I want to have when you sum this one together. Then for the y direction, don't forget ry, it becomes what? We are going to have we are not going to have b on the y-axis because this one is already on the x component. So that is to say, what we are going to have only is what? Ay sin theta. We don't have any other vector acting along the y direction. But how many vectors do we have here? We have the b going that direction and the resolved a going in that direction, making what? Two vectors going in that direction. And when two vectors are moving in the same direction, what you do is to add them together. Now, if you now put them in that formula I gave you, I gave you r square root of what? Rs square plus what? Ry square. Let's put it there. Don't forget that a cos theta plus b all square. First of all, let's just deal with this one first for Rx. I'm going to have what? A squared, meaning the same thing as what? A cos theta plus b. Let's just make it simple for our viewers to understand what we are doing. That means this one now we want to square it. So to find r square. Now be a cos theta times a cos theta, we have a cos square theta. Then this times you would have what? Plus ab cos theta. Then this one now times you have what? ab cos theta. Then this times you would have what? Plus b squared. Now what about what? This one is for rx. Now what I want to have is what? Ry becomes what? A sin theta all square. Don't forget this one is square, this one is square, r square. So what I want to have is what? I want to have a, no need to put ay there because ordinary a. Then a sin theta, then ordinary a here. Because if you resolve this one here, you have a sin theta, a cos theta. So I would have what? A square sin square theta. Now let us put the two of them together. If you put the two of them together, we are going to have it as what? A square, let's put what? R x square plus ry square. Let's put it together. We are going to have it as what? A square cos square theta plus ab cos theta plus ab cos theta. Then what do we have? We have a plus b square plus a square sin square theta. Now if you combine this and this together, you want to have what? A square cos square theta plus a square sin square theta. After having this one, and what about this one? This one give us what? Plus 2ab cos theta. Plus 2ab cos theta. Then what do we have now? We have taken this and have taken this. Then what we have taken this and this, remaining what? Plus what? B square. Now, if you combine these two together, you see that this one will give us what? A equal to what? Cos square theta. Bring out the a, factorize a square out. So plus what? Sin square theta. You understand what I'm saying? So this one now be what? Because a is common, a square is common between these two. Plus what? 2ab cos theta plus what? B square. So now, this one now, don't forget identity. A square, or let me say cos square theta plus sin square theta equal to 1. If you don't know it before, thank God you are knowing it now. So this will become 1. 1 times a square give us what? A square. Let's bring this one down. Become b square plus what? 2ab cos theta is equals to what? R square. Now, having gotten this one now, if you check, cos theta is the same as minus cos 180 minus theta plus cos. Don't forget, in the second quadrant, that's that. In the second quadrant, you have what? Cos 180 minus theta is the same thing as minus cos theta. If you look at it very well. Now, what I'm saying is that if you have cos 60 degree minus cos 60 degree is the same as cos 120. Because if you put 60 here, 180 minus 60 will give us what? 120. Cos 120. And cos 120 is synonymous to what? Minus what? Cos 60. Now I'm going somewhere. So if you know this one now, no need to what bother ourselves again. Let's clean it up. Now what we are going to do now is to replace what? Replace 2ab plus 2ab cos theta with the same thing as what? Minus 2ab cos 180 minus theta. Now look, don't forget that this one now will come out with minus. Minus will give us what? Plus. So that means I'm not altering, because this one is more or less like the same thing as minus cos theta. So minus cos theta minus will give us plus. So to rearrange it, you are now going to have r square equal to what? A square plus b squared minus 2ab cos 180 degree minus theta, which will now give us r equal to what? Square root of a square plus b square minus 2ab cos 180 degree minus theta. Now you can now see that using vectorial method or vectorial representation method, and also using parallelogram method, you would arrive at the same answer, which I'm going to see a question on that in our next video. But till then, I hope you enjoy the video. Make sure you go through it over and over again. I remain Engineer Alide, the shortcut master. Please share, follow, and like our video. Thank you. God bless you.